So what I want to do now is introduce someone who's working on a very crucial function and piece of the Ethereum ecosystem. Smart contracts, to paraphrase my friend Piper Merriam, writing smart contracts is a lot like writing code for the space shuttle. If something screws up, it can screw up in a very large way with negative repercussions for interested parties. And we've seen this over and over again. So our next speaker is Santiago with OpenZepplin. OpenZepplin is a smart contract security function or a service that's aiming to fix a lot of these issues before they happen. So let's give it up for him.
Thanks a lot for the intro. Okay, guys, well, thank you for being here. Can you hear me okay? No, actually, let me see if I can remove this. Hello, can you hear me okay? Okay, perfect. Well, thank you all for coming. Well, my name is Santiago. I work at Zeppelin. We're a consulting and auditing firm. We have been working with many of the folks here, actually. We have worked with Augur, Prism, Omise. We've been working with the people from StoreJ, Brave, Golem, and a few others. And besides our auditing services, we also work on OpenZepplin, which is what we will be reviewing today. And we're also working on Zeppelin OS, as you can see on my t-shirt, which is the upcoming project we're working with. We'll discuss it by the end of this talk. So, well, first of all, what is OpenZepplin? Well, there has been already quite a good intro, but basically, it's a set of reusable smart contracts, open source, generic purpose for you to bootstrap your project and build on top of them and get for free a lot of features which are already reviewed and audited and contributed by the community. The focus in OpenZepplin is in security, which is also basically the main drive behind OpenZepplin, the reason why OpenZepplin came to exist. I'm not sure if you guys are familiar with the list presented there, but it's basically a compilation of famous hacks on Solidity smart contracts, which account for several millions of dollars. So basically, the idea of OpenZepplin is to provide a secure base, a secure set of smart contracts for you to build atop on them, and to try to prevent these kind of hacks by providing a secure base for you to build your projects on top. So OpenZepplin was presented about a year and a half in DevCon 2 with the idea to try to address these kind of problems. And since then, adoption has been skyrocketing. We have around 3,000 weekly downloads of the framework. We have a very active Slack community with around 300 people weekly. It's not just regarding OpenZepplin development, but you can also find discussions on general Ethereum development, blockchain development. It's actually a very active community. You're welcome to join. We account for about $4.5 billion US that are currently running on the Ethereum blockchain using OpenZepplin contracts. This is basically just some of the projects that we know that make use of OpenZepplin, their total market cap combined. And the project, the repo on GitHub right now, has about 100 contributors. Actually, we'll be very happy if during this hackathon, or after this hackathon, we can also count some of you guys among that set. Okay, so what are the design guidelines behind OpenZepplin? Well, first and foremost, security, which was the driver behind the framework and what actually motivated us to build it. The idea is to make sure that every single line of code is thoroughly reviewed, it's secure for you to use. And the next goal of the framework is for it to be simple. Not as simple as in easy, but simple made easy. We want to make sure that it's modular, that it's clear to use, that its contract has a very defined responsibility. We basically believe that clear code, and that's also where naming matters comes in, that clear code also leads to secure code. That if it's clear what each of your contracts and each of your functions is doing, then it's easier for you to write something secure. Everything in OpenZepplin is, of course, thoroughly tested, has quite a large suite of unit tests that run on every commit. And there are also runtime assertions to make sure that all preconditions and all invariants on the contracts that are deployed there hold. You will also notice that even though we have about 100 different contributors, The code style is pretty consistent. The code base is pretty uniform. And also all major releases are audited, and we're also working with external auditors to have audits on every single release. Even though we are an audit firm ourselves, we believe that it's not a good practice for the same company being behind the development and the auditing of the same product. So let's get started. OpenZepplin is distributed as an NPM package, so installation is just via NPM. Please don't copy-paste the contracts, don't attempt to modify them directly, don't go directly into master and GitHub and copy-paste whatever you find. Make sure you're always working with the release. If you just stumble into GitHub and copy whatever you find, you may find an intermediate version that is not as secure as we would like it to be. Always work with the latest release. Basically, the way OpenZepplin works is by having a set of base contracts from which you can extend. And basically, they will provide different features to your contracts, or you can extend from one of the different verticals we have, so you don't have to re-implement everything yourself. Canonical example would be if you want to build your own Crowdsale with your own token, rather than implementing all the functionality from scratch, you only need to extend from, you don't see anything. You only need to extend from Crowdsale contracts or ERC20 contracts and basically sprinkle whichever other functionalities you want to add. Let's say you want to have a token that can be paused. It's okay, you can actually inherit from pausable, which will add the trait for a smart contract to be paused in case of an emergency. We'll actually deep dive into all of this during this talk. But basically, so you have an idea, it's a set of smart contracts from which you can extend and override as needed if you want to implement custom functionality. So let's go on to the code. Rick and Morty reference. So basically, the first thing we have in OpenZepplin is a library called SafeMath. For those of you who don't know, all arithmetic operations on Solidity are unchecked, meaning that if you're adding two integers and it overflows, it will simply wrap around and you will never know. Same happens with division. Well, division is actually okay. Same happens with multiplication. Same happens with subtraction. So it's a good practice, rather than using directly the arithmetic operations in Solidity, to use one of these wrappers that basically execute the operation and check that there hasn't been an overflow. So we provide the SafeMath library, which actually the implementation is very simple, just executing a function and make sure it's okay. You will see there are methods for all the form-based arithmetic operations. Usage is pretty simple. Let's say you have a contract that performs regular arithmetic operations. What you want to do is just add the using keyword in Solidity that allows you to call the library methods directly on that object and just use one of whatever arithmetic method you need. Ideally, you should not have any plus signs or minus signs on your code. You should be delegating everything to SafeMath to make sure that you're not in the risk of falling into an overflow. What else? Well, nowadays tokens are pretty much everywhere on the Ethereum ecosystem. The most widely adopted standard is ERC20. If you want to roll out your own ERC20 standard, you basically need to implement all those methods. Basically for gathering what's the total supply of the token, querying the balance of someone, transferring, approving transfers, and a few more. So OpenZepplin already ships with a thoroughly reviewed implementation of the ERC20 token, meaning if you want to implement your own token, you only need to extend from standard token and basically define how that token is going to be initially set up. The most simple example is you define an initial supply and assign that supply to you. Basically the owner, the person who deployed the contract. Of course, using this, you can build whatever else you want, but this is pretty much one of the easiest flavors of ERC20 token that you can deploy. Usage is straightforward. You just deploy the token. You can query the balance. You can transfer balance from the owner to a different recipient, so you can distribute around the token. And then, well, as you can see, if you query the balance afterwards, you'll see that has indeed decreased. This is basically regular JavaScript code with async await helpers to try to help a bit from the promises. You will see a bit of this on the code that we'll share actually in about 10 minutes or so. So OpenZepplin not just has an implementation for ERC20, we also have implementation for ERC721, which are non-fungible tokens. With non-fungible, I mean identifiable tokens. One of the most known examples, the CryptoKitties, also land from the decentralized project. The idea is that, well, one kitty is different from another kitty because it may have blue eyes, brown eyes, whatever it is. So it's not fungible, meaning that you can just trade one kitty for another because they're unique, and we love each of them in different ways. ERC827 is basically an extension for ERC20. This is a fungible token. It adds some transfer and call helpers in case you want to execute an operation. And we're also on the lookout for other EIPs that we want to implement and add to the OpenZepplin framework. Actually, if you stumble upon a proposal that you consider it's worthwhile to be added to the library, you're more than welcome to open an issue, start the discussion, and ultimately send a pull request to OpenZepplin so we can add your code, your implementation of the EIP to the library. So, what else? We also have, well, tokens are one of the verticals we provide. We also have different aspects within the library. Think of aspects as basically traits or features that you want to add to your smart contract. Very simple example would be an ownable contract. This actually is part of the ownable contract that you will find in OpenZepplin. So let's say that you have a contract and you only want certain operations to be executed by you, by whoever is deemed the owner of the contract. You only need to extend from ownable, and from there you'll be able to use a modifier for the functions that you want to decorate and saying, okay, these functions should only be called by the owner of the contract. The way to leverage this is thanks to Solidity's multiple inheritance, so you only need to extend from all the traits that you want to add to your smart contract. For instance, let's say you have a mintable token. Mintable means that you basically have a method to generate more tokens on the go. The way this is implemented, actually is straightforward. You just add a method that you call. You say, hey, I want to mint this many tokens for this guy, and it gets automatically added to the balance. This, of course, needs to be a public method if you want to call it from outside the contract. Thing is, you don't want anyone to calling into your contract and generating more tokens as they go. So you only need to extend from ownable and add the only owner modifier to a method. That way, only you will be able to invoke it. We provide many different aspects on the library. Regarding ownership, well, we have the ownable we just reviewed, claimable and heritable, which are basically a few modifications on the ownable concept, all the way up to a role-based access control in which you can define different roles and different accesses for them on your smart contract. We also have a pool payments implementation. Basically, if you want to transfer Ether to someone in Ethereum, it's a good practice to implement it as an async payment. The idea is that as soon as you're executing a transfer to a different address, transfer of Ether specifically, code gets executed on that smart contract, and that code could throw, could abort, could interrupt your application flow. So it's a good practice, instead of actually sending Ether, to assign Ether to that address so they can later come in and claim it. That's typically defined as a pool payment or an async payment. There are helpers in OpenZepplin to implement that. You just, rather than transfer, you async transfer the method to the beneficiary so they can later come and basically claim it. We also provide some lifecycle traits. There is a pausable implementation in case you want, as the owner, to pause execution of a smart contract in case something has gone wrong. Also a destructive implementation, basically to call suicide on it. The last vertical we're going to talk about are Crowdsales, which actually are very common, perhaps even too common nowadays on the Ethereum ecosystem and come very coupled with tokens. The idea for a Crowdsale contract is basically to receive Ether and send tokens back to the beneficiary. A typical interface would look something like this, a Crowdsale that runs through a period of time, defines an exchange rate from Ether to tokens, and sends all collected funds to a specific wallet, and provides a default payable function where anyone that sends Ether are ultimately going to receive the tokens back, allows to buy tokens on behalf of someone else, and provides some basic information on whether the Crowdsale has finished or not. Usage, again, is straightforward. You can deploy the OpenZepplin Crowdsale contract directly. You will be able to query it for how much funds have been raised so far. And as you can see, well, on the fourth line where you send the transaction, where you actually send Ether to that, you can then query the token balance associated to that crowd sale from the beneficiary. And you can see that they actually get a specific amount of tokens back from, based on the amount of Ether that they have sent. We're going to share all this code with you in just a couple of minutes. Now, typically you will want to customize your crowd sale. You don't want a vanilla crowd sale. You want to modify its behavior in certain points. So the crowd sale contract provides certain internal methods that you can basically override or extend to add your custom functionality. You can basically choose what's going to be your token contract that's going to be used. You can define how many tokens exactly will be allocated for each purchase. You can define when a purchase is valid, such as whether an investor is whitelisted or there's a minimum amount of funding in the purchase. And you can also define how funds are going to be ultimately collected. Let's say you don't want to forward funds immediately, but you want to hold them until you hit a minimum target, or you want to send them to different wallets as you collect them. Basically, you can override all that functionality. The way it works is straightforward. You just set up your crowd sale contract, and you override, in this case, the token amount method that will allow you to specify a different amount of tokens for whoever is making a purchase. This example, let's say you want to throw an extra 20% to whoever has purchased, so you can just modify the calculation on the token amount from the rate times the way contributed with an additional multiplier. Also, you can extend from some crowd sale flavors that are already implemented, such as capped crowd sale or refundable crowd sale. We have capped, refundable, and finalizable. The first of them allows you to execute custom functionality when the crowd sale ends, such as minting tokens for a team or foundation. A capped crowd sale, which basically stops as soon as a certain amount of Ethers has been collected. And the refundable crowd sale, which allows you to define a minimum goal so that it's not reached, all investors can actually claim their Ether back. We're also working on different more flavors that will be coming on the next release and the one after that. A whitelistable crowd sale, where you can define a set of vetted investors who should only be the ones that access the crowd sale, mostly for KYC purposes. A pausable crowd sale, in case you want to stop collecting funds at some point, in case something has gone wrong. Caps per user, so each investor can contribute up to a certain amount of money. And the pre-minted crowd sale, so rather than minting tokens on the go, you provide the crowd sale with a token that has already been minted, and you just use the crowd sale to distribute those tokens among your investors. So the idea now is actually to take about 15 minutes or so you guys on your own computers can work on an exercise. We have set up a sample repo. We'll share the URL in a second. But the idea, what you will find there is an already set up truffle project. You only need to clone it, run npm install, npm test to make sure everything is OK. And you will basically find a crowd sale and a token contract with some extension points defined and some tests skipped as well. The idea is for you guys to implement the necessary code for those tests to pass. The idea would be to work granting bonuses to the contributors. So let's say that you get a purchase where with a certain amount of Ether, let's say someone contributes over 5 Ether, you want to send an additional number of tokens. You want to mint additional tokens for the owner for the crowd sale once it finishes. So let's say 20% of all the tokens that have been sold, you want to mint in addition for the foundation, for the owner, for whoever it is. And also if you want to jump into a whitelist implementation, we already have one in the making, but it's actually a good practice to work on defining, okay, when a purchase is valid and trying to check different criteria. One of them could be having a set of pre-approved investors. Oh, sorry. Here on this URL, you'll find the repo that you can clone and basically get all the information, all the code already set up, so you don't have to work on the bootstrapping of your project. You can also feel free to use this repo for your hackathon project later. Everything is taken care of for you, so you can easily start hacking, test, and make sure that everything is working properly. Will take about 15 minutes or so. Yeah, I know it says 20 down there, but OK. Between 15 and 20 minutes. So you guys can hack. We'll also take questions during that time. And don't go anywhere because we will wrap up after 5 minutes. We'll present which will be the prizes we'll be awarding for usage of OpenZepplin during the hackathon. And we'll also be presenting the project that we are working on, which is basically Zeppelin OS and, well, all the things we're working on later. So please, guys, start hacking. And in the meantime, if you have any questions, raise your hand. We'll be happy to answer. And if you want someone, if you need help actually with the hands-on exercise, just let us know. There are several of us around here that can go around and help you and get set up. We have Matt, we have Manuel, so pretty much there are quite a few people around here experienced on the framework, so I'm sure they can provide help. Okay, guys, if you have any questions, we'll be here taking them. Okay, so we have a question on what's the rationale behind, let's see, ERC 827, which is the approve and call. Basically, for many applications, you want to use your tokens as form of payment, if you want to say so. So what you typically do in ERC20 is you send an approval to a smart contract that is going to provide the service. Could be an exchange, could be a service provider, whatever it is. And then you call a function on that smart contract saying, OK, please do that for me. That smart contract is going to take your tokens after you have done the approval and execute some logic. That means that you need 2 different transactions for doing that. The first to the token contract for the approval, the other one to the service provider for execution. The idea behind the approve and call is you just send one transaction to the token contract saying, OK, allocate this much money to this contract, and then call him saying, hey, this guy wants to execute this, or that.
Check when the microphone
I'm not sure if
comes on.
there's right now an extension for 721. I know there's 821 going around. I'm not sure if it adds that. There is work on that. It's keep an eye on ERC 821.
821 would be this. 821 would be the 721 version of 827.
Not exactly 827, but yeah, it will include stuff like that that allow you to basically validate the transaction, execute code upon a transaction. Yeah, there are actually many different flavors of 827. Some of them that actually require execution, require a fallback function to be implemented, or you also have 777, which is a standard which is getting a lot of traction, which is not backwards compatible with ERC20. So the ones you want to look at are the ones listed here, 777 and 821.
Thank you.
Welcome.
The question was if OpenZepplin provides some voting functionalities, and the answer is unfortunately not. That would be awesome to.
Are you planning to add something like that?
I mean, we are always open for contributions to the framework. So if you build something this weekend, you're very welcome to submit a pull request.
Another question. If you have a standard token that you want to burn for, say, like a 721 token, like Decentraland Mana did something like that, I think. Is there a way using MetaMask or something to pay with your standard token to a smart contract accepting that standard token instead of Ethereum?
Okay. Yeah, basically what you need to do is build your own dApp that it's going to send the transaction to the token contract, instructing it to either burn or transfer to another contract that is going to take care of the burning. But still, you will need to have some Ether on your account to actually pay for the gas to execute the transaction. There is an EIP, I think it's 826, that is working on basically signing transactions and delegating them to someone else for execution. So if you have a standard token, you actually don't need any gas to perform the transaction. You basically pay a fee to someone else to execute the transaction on your behalf. So they pay the gas for the transaction, and they get tokens as a reward. That's 826. It's still under development. We're actually working on that with the folks from YouKnow.
Thank you.
Welcome. OK, folks, we'll wrap up. We'll still be around here in case you have any questions with the hacking. But basically, we'll make a quick wrap up and present what we are working now. So the idea after OpenZepplin, the project we are working on is Zeppelin OS. You can get free Zeppelin OS t-shirts on our booth. The idea basically is to, right now with OpenZepplin, what you need to do is you basically extend from the contracts and you deploy them, you deploy your own versions on chain. The idea is to have a set, we call it a kernel of on-chain libraries, which you can basically depend on for your smart contracts. So rather than deploying the entire contract each time you want to make a deployment on chain, you just reuse the code that's already deployed, saving you a lot of gas and making sure that of code that is already available there. So instead of deploying a complete contract, you just deploy a little bit of your contract that basically is going to delegate all codes on the on-chain library. The idea is for these libraries to be upgradable, meaning that if we want to add a feature, we detect a bug or an issue on them, and we need them to be fixed, we have an upgradability mechanism so that the contracts you have deployed can automatically call a different backing library with a different code. Of course, having the keys to that upgrade, it's quite a security risk. It's a single point of failure. So the upgradability mechanism, of course, is going to be opt-in. It's going to be managed by a decentralized governance system. We also want to provide alternative execution models. We'll be rolling out a scheduler for you to be able to run async operations, to execute operations without having to pay for the gas and providing a bounty, and even setting up a marketplace so that different service providers can have their interface easy to use directly from Zeppelin OS. And we're also aiming to provide off-chain tooling to support all of this, so it's actually easy to get started and get up and running, integrating with all the contacts that are already deployed. Zeppelin OS right now, it's on prototype stage. We're evaluating different upgradability and governance mechanism for the MVP. You can find more at zeppelinos.org. You have a link to our blog post, white paper, and basically all the information you need to get acquainted with the project. Right now, as I was saying, our focus is in the upgradability part. And, well, of course, reusing code directly on chain. We'll also be awarding prizes for folks in the hackathon. Basically, we'll be awarding 3 different prizes. One of them is best use of OpenZepplin. The other one is best contribution to OpenZepplin. So if you're writing something and you think it's a good idea, it would be a good addition to the framework, you're welcome to open a pull request to it. And that would also be a candidate for one of the prizes in the hackathon. And we'll also be awarding a prize for the best prototype on Zeppelin OS. If you are more interested in this, remember to go to zeppelinos.org. You'll also find a link to the GitHub, which is Zeppelin OS Labs, where you can see what we have been working on, and you can propose different upgradability versions or whatever you think would be an interesting contribution following the white paper we have. Something more, we'll be awarding crypto collectibles starting tomorrow. So those of you who stop by our booth, besides getting a free t-shirt, you may even get a free crypto collectible if you convince us that you're going to build something awesome using OpenZepplin. Starting tomorrow, just drop by our booth and you'll be able to get an OpenZepplin collectible. Okay, so now we're finally finished. Again, if you have any questions regarding the starting project or OpenZepplin itself, just let us know. You have all our contact information there. Well, thanks a lot. Well, have a good lunch.